Welcome to Study Loop.
Because we have three ways of conduction: walls, roof, and windows, we simply have to add all three conductivities. So Q by T in this case is Ka by L of the first, that is walls, plus Ka by L for roof, plus Ka by L of windows times delta T. So that is, for walls, it's 0.023 joules per meter second degree Celsius, and the area is 410 meters squared divided by the width of the walls is 0.195 meters. Now that similarly, we add the other two terms. For the roof, it's 0.1 joule per meter. K is 0.1 joule watt per second degree Celsius. The area is 280 meters squared divided by the width is 0.055 meters. Plus for windows, K is 0.84 watt per second degree Celsius. Area is 33 meters squared divided by the width is 6.5 into 10 power minus 3 meters. All of this needs to be multiplied by 38 degrees Celsius, the temperature difference. It's 23 minus 15, by the way. This, when you substitute into a calculator, turns out to be 1.832 into 10 power 5 watts, which is about 1.8 into 10 power 5 watts. This is how fast the heat is dissipated. Now, as the room is heated, the temperature inside goes from 12 degrees Celsius to 23 degrees Celsius. The outside temperature is minus 15 degrees Celsius. So the temperature difference goes from 12 minus 15, so 27 degrees Celsius, to 23 minus 15, which is 38 degrees Celsius, which means the average temperature difference corresponds to 32.5 degrees Celsius. So we add some heat. This heat is used to raise the temperature of the room, plus there is heat is also lost due to conduction. So the amount of heat needed to raise the temperature is simply mc delta T, which is in this case, where in this case the mass of the air is rho v, where v is the volume and rho is the density of air, and of course c is the specific heat of air, and delta T is the change in temperature. Remember, this is 23 minus 12, which is 11 degrees Celsius, plus the conduction temperature is simply Q by T times how long, the amount of time it takes, which is 30 minutes. So that's 30 minutes into 60 seconds per each minute. These milliseconds, 1800 seconds. By substituting our values, we know that the density of air is 1.29 kg per meter cube. Volume of the house is 750 meter cube. C of air is 0.24 kilocalorie per kg degree Celsius, but we need to convert it into joules. So we know that each kilocalorie is 4,186 joules times the temperature difference is 11 degrees Celsius. It is 23 minus 12 plus the heat lost due to conduction is Q by T, as we calculated in the last part, is 1.8 into 10 power 5 joule per second times. Remember that we want to measure this value at 32.5 degrees instead of at 38 degrees. So we multiply it by 32.5 by 38 times the 1800 seconds, which gives us 2.5 into 10 power 8 joules. Now, let's say our month has 30 days and it means 90% of all gas consumption. So that's 0.9 of all gas is used in keeping up the heat. So that's Q by T of conduction times the total time. So the amount of heat produced by the gas is 1 by 0.9 times, we know that Q by T is 1.832 into 10 power 5 joule per second. And the time is 30 days. So that's 30 days with each day having 24 hours, with each hour having 3600 seconds. So that gives us 5.276 into 10 power 11 joules. Now, each kg of gas gives you 5.4 into 10 power 7 joules of energy, and that costs $0.080, which is 80 cents. I'm sorry, 8 cents. So the total money the total cost is equal to the total energy, which is 5.276 into 10 power 11 divided by energy released by each kilogram, 5.4 into 10 power 7. This is the number of kgs of natural gas required. So to find the cost, we simply multiply this by 0.180, 0.080, which gives us our cost in dollars, $781.65, which is about $780. Very costly indeed.